right, so we have three people standing on a stage. We are going to classify the triangle they make by their sides and by their angles. So their sides are easy to see. How many sides are congruent? None of them. So that makes this triangle scalene. And then I know you drew the triangle, so it's harder to see. But we're going to use a piece of paper to figure out if the biggest angle is less than 90 or more than 90. I'm going to teach you a trick. You'll learn it in a later section, but in triangles, the biggest angle is across from the largest side. So which of these is the largest side? 8 feet. So then across from that is the biggest angle. So we're seeing if this angle is less than 90 or more than 90. Those are the two options. So I'm going to use the edge of my paper, which is 90 degrees. So I'll try to move out of your way, Braden, here in a second. All right, so our thoughts? It's bigger than 90, so that means it is obtuse. All right, so scalene, obtuse. Is it? Scalene, obtuse. You're going to draw two more pictures. I will try to help you with them because my last class freaked out with their lines. That's all they are. If it were me and I were drawing this first one I would draw these lines first and then go from there. That's just me. We're drawing this on the back. Beautiful, Braden. Beautiful.
You can draw the arrows too in the planes.
Yes, no, maybe so. Doesn't really matter. This second one, it's a triangle. Just the lines don't stop at the vertices, so draw it however. But you need both drawn because I'm not going to pause for you to draw the second one. I would write the 40 and the right angle and the right angle. You don't necessarily need all the numbers. All right, ready?
No.
Well, give you like 15 more seconds. Okay. All right, so this is the first picture. We're going to find all of these angles. You want to start where the most information is, which on here is the left side. So which angle would we like to find first, knowing we have a right angle and a 40-degree angle? We could find angle 1. It is in a triangle. So how do we find the measure of angle 1? 90 plus 40 minus 1. Yep. 90 plus 40 is? 130. Subtract that from 180. Correct. So we got one of them. What else can we find knowing these angles? We can find angle 3, which is 50 because they're vertical. What else can we find?
2 and 4.
We can find 2 and 4. What relationship does angle 1 have with angle 2? Linear pair, which means they're supplementary. So what is 180 minus 50? 130, which means angle 4 is 130. All right, and then I think Wesley said he wanted to find angle 5. We definitely can. So it is in a triangle. So we can add 90 and 50, which makes 140. Subtract that from 180, and that makes, yeah. So angle 5 is 40 degrees. So which one do we want to find next? Two different answers, but either one is fine. We could find 6 first. What relationship does 6 have with 5? Linear pair, so they're supplementary. 180 minus 40 is 140. So then angle 8 is also 140. It's a linear pair with 40 as well. And then there's one left. What is angle 7 going to be?
90.
It is 90 because it's a linear pair with 90. Questions on any of these? Okay. Here is the second one if you didn't get a chance to finish drawing it. Which angle would we like to find first? Angle 3, that's fine. What relationship does angle 3 have with 90 degrees? They're a linear pair, which means they are supplementary. What is 180 minus 90? 90. What relationship does 90 have with angle 4? They're vertical, which means they are, they're congruent. It's going to be 90. What do we want to find next? We can find angle 2, which is 68, because it's vertical with 68. While we're here, let's find angle 1. Angle 1 is supplementary with 68, so 112. You subtract 68 from 180. So from here, what can I do to find angle 5?
Add 4.
Yeah, add angle 4 and angle 2, and then subtract them from 180, because that is a triangle. So we got 90 and 68, which makes...
28.
You're okay. 158.
Yeah.
And then subtract that from 180, which is 22. And then 6 and 5 are a linear pair. So what is 180 minus 22? Yeah, we kind of just did the backwards. So it's 158. That's it. Questions on any of these? Wonderful. Go ahead and turn to the front page. We already did this. We're going to find the measure of angle 1. So looking at this triangle, do I have enough information on the inside to add the 3 angles up and set them equal to 180? I do not. So we don't know what this angle is, right? It's 1. Is it 1 degrees? No, that's just the name of it. Can I call it x? I cannot. Isn't x already in the problem? So I can't rename it. So I can't use that property. I'm going to have to use a different one. 5x minus 10, it is obtuse. But what else do we call 5x minus 10? It is an exterior angle. So the exterior angle is equal to the 2 interior angles that are not adjacent to it. That would be 40 and 3x. You can add them, and they will equal the exterior. So that's what we're going to do. 40 plus 3x equals 5x minus 10. Subtract 3x. 40 equals 2x minus 10. Add 10, 40, and 10 make 50, which equals 2x. Divide by 2, and x is 25. So we need to use that to find the measure of angle 1. Where would you like to plug that in? There's no wrong answer. We could plug it into 3x. So we're going to plug it in here. 3 times 25 is 75. So we know one of our angles is 75, another is 40. We want to find the last angle inside of this triangle. So we're going to add 75 and 40, which makes 115. And then we're going to subtract them from 180. 180 minus 115 is 65. Even if we had plugged it in on the outer one into 5x minus 10, what is 5 times 25? It is 125. And then minus 10 still would have made 115. And what relationship does angle 1 have with the outer angle? They're a linear pair, right? So you still would have subtracted 115 from 180 and gotten 65. That's why I said there was no wrong answer. Questions on this first one? Okay. The second, we want to find the measure of each acute angle. How many acute angles are in this triangle? Two of them. So we're going to find both. We know the three angles inside of a triangle add up to 180. So we got 2x. We have x minus 6, and then we have 90. And they equal 180. Combine like terms. We got 3x. And then what is minus 6 plus 90? 84. Subtract 84 and 3x equals? It's 96. Divide by 3. And x is 32. Yes, ma'am.
Can you technically do like 2x plus x minus 6 equals 90?
Correct. All right, so we want to find our two acute angles. So 2 times 32 is 64. So there's our first one. And then our second is x minus 6. So 32 minus 6, which is 26. Perfect. So now we're all cut up. We're doing 5.2. This is where you want 4 highlighters. It just makes the pictures a lot easier. It's about congruent polygons. So what does the word congruent mean? They're same measure, same length. All right, doesn't mean they're the same, but they look the same. So what I did this morning was I took a piece of paper, I folded it in half, and I cut out a triangle. These two are congruent because when I lay them over each other, they are exact, right? So even if I flip one of them, are they still congruent?
Yes.
Yes. Even if I bring one all the way up here, are they still congruent? Yes. So in this section, you're going to be asked, you're going to have two congruent shapes, whether they be triangles or quadrilaterals, and you're going to be asked which angles are congruent. So like these two at the top. Even though I pull them apart, they're congruent to each other. All right, they correspond with each other. Certain side lengths correspond and things like that. So we're going to start here. You have fill in the blank. When two figures are congruent, I believe that's your first blank. When two figures are congruent, there is a correspondence between their angles and sides. When two angles are congruent, there is a correspondence between their angles and sides. I'm sorry if one of the blanks is not big enough for the word corresponding. It happens. So when two figures are congruent, there is a correspondence between their angles and sides, such that corresponding angles are congruent and corresponding sides are congruent. So corresponding angles are congruent and corresponding sides are congruent. Corresponding angles are congruent and corresponding sides are congruent. All right, so if you look at my picture, obviously it's got color, but when you get to a quiz or test, it's going to be in black and white. So here's what you're going to look for. If you look at angle A, it is at an angle with one arc, correct? You would match it to the angle on the other triangle that also has one arc, which would be angle D. So you can go ahead and take your highlighter if you would like, and you can highlight A and D in the same color. Makes things a little bit easier to see. The same thing with B. It has 3 arcs, so it corresponds with E. So you go on to take a second color and highlight those. And then C has 2 arcs, so it corresponds with angle F. Okay, with your third color. So these two triangles are congruent. One of them has been flipped and moved a little bit. But other than that, they are congruent. So that means the angles that you just highlighted are congruent to each other, same measure. And that means the corresponding sides between them will also be congruent. So in the boxes below, it says corresponding angles and corresponding sides. We're going to fill that in with our angles and our sides. So corresponding angles are congruent. Corresponding sides are congruent. Let's start with angle A. So in that box, go ahead and write angle A. And angle A is congruent to angle D. So remember, use the angle symbol. It looks like a less than symbol, also a slanted L, however you want to look at it. Angle B is congruent to angle E. And then angle C is congruent to angle F. So those are the congruent angles. We'll list the congruent sides. Do you see how it's color-coded? The order that you name it in matters, and you'll be thankful it matters here in a second when we go to do math with this. But because they said A and then B, we need to name the second one the same. So if they said A first, on the second triangle, what would correspond with A? D. And then they said B second, what corresponds with B? E. So you do have to list it as DE if the first one says AB. Okay, they both have two dashes there that show they are congruent. So that's the first set. The second says BC. So if I say BC on the first triangle, what am I going to say on the second? EF. And then last, we got AC, which corresponds with and is congruent to DF. And then what I would also note is that this question is not hard on the test. This was not a complicated topic, right? But the way that it's worded, some students don't know how to answer it. It will say list all pairs of congruent corresponding parts. So that's what it's going to look like. And when it says list all pairs of congruent corresponding parts, it just means list all the congruent angles and list all of the congruent sides. So if you see this phrase, this is what it's asking you to do. The last blank on this page says congruent statement. Again, it's not difficult, but if you don't know what it means, then it will not help you in the future. A congruent statement says this shape is congruent to this one. The order of the letters matters the most here, and we're going to name each triangle. This is the same picture, just moved up. So if I said triangle ABC, go ahead and write that down. Triangle ABC. We're trying to name it congruent to the other triangle. So we're saying triangle ABC is congruent to. Make sure you have your triangle symbol. And then we said A first. What corresponds with A? D. We said B second, which corresponds with E, right? And then they said C third, so that means F needs to be third. So that is one option for a congruent statement. You could name these many, many ways. If we said triangle BCA, what would we name the second triangle? Yeah, not EDF. EFD. So EFD. Okay? Questions on a congruent statement? Yes. So, do you see the congruent statement at the top? You can pretty much ignore the shape and only look at the congruent statement. If you have highlighters, you can highlight them if you want. A and C are going to correspond. B and D G and E. And then H and F. Some people try to use their eyes, and this one especially would be more complicated just because there's two right angles. So the statement itself is enough to answer all of the questions. So we're going to use it. So the first part says identify all pairs of congruent corresponding parts. This means we're going to name which things are congruent. So starting with angle A, because I'm just going to read the statement. Angle A is congruent to angle C. Angle B is congruent to angle D. Angle G and angle E. And then last, what is that? Angle H and angle F. All right, so have we listed everything that's congruent in these two shapes? We have not. We only listed the congruent angles. If they're completely congruent, it's not just the angles, the sides are going to be congruent as well. So you can, again, use the statement itself. You can start with AB. What is AB going to be congruent with on the other shape? CD. What is another side? We could say GH is congruent to EF. We got two more, because remember you got four sides on each of them, so we should have four statements. So what is another? Correct, BG. So we said first we said AB, then we said GH. So he just said BG, so that's correct. BG is congruent to DE. And then we only have one side left. AH is congruent to AHCF, yes. AHCF. I'm going to guess. You read a lot in English, no?
Oh, yeah.
Okay. All right, then we're going to find the value of x. Is x an angle or a side? It's an angle. So it's attached to angle H, correct? What is angle H congruent to on the other shape?
F.
Angle F. So that means 4x plus 5 is equal to 105. Subtract 5. 4x equals 100. Correct. We just answered that whole problem. Questions, comments, concerns? Wonderful. So again, you have this statement. You don't have to highlight every time. You can read if you want. But, I'm going to highlight. We got D and S will be congruent. E and P. F and Q. And then you got G and R. This is the last bit of highlighting. We're going to find the value of x and then find the value of y. So there's an x in two places. Which of these is easier to work with right now?
Top.
The top one, right? The 2x minus 4. Is that an angle or a side? It's a side. It's QR. What does QR correspond with on the other quadrilateral? FG. So that means 2x minus 4 is equal to 12. Add 4. 2x equals 16. Correct. X equals 8. Perfect. Then it says find y. There's only one y, correct? Is it a side or an angle? It's an angle. It's an angle Q, which corresponds with angle F. So 6y plus x equals 68. So some people try to solve this like it's a system of equation or something. But don't we know the value of x? We do, right? It's 8. So we're going to plug it in. So 6y plus 8 equals 68. Subtract 8. Correct. 6y equals 60, so then y is 10. This is called the third angles theorem. This theorem in and of itself is not very difficult, so you write that down, third angles theorem. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent.
Just like the
Transversal?
we're going to like A, B is congruent and C, B is congruent.
Oh, transitive property? Kind of. I see what you're thinking. If two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. So, here's what that is saying. If A and D are congruent, and E or B and E are congruent, that means C and F have to be congruent. So let's show that with some numbers. Let's say angle A was 40 degrees. We're not going to be accurate at all, just so you know. And angle B was 60. All right? If B is congruent to E, that means E is also 60. If A is congruent to D, that means D is also 40. So let's find the third angle in these triangles. What is 60 plus 40? 100. So that third angle has to be 80. So because two angles are congruent to two angles, their third angle has to be congruent. Because what is 60 plus 40? Still 100. And 180 minus 100 is still 80. That's all this theorem is saying. If two angles are congruent to two angles, the third angle has to also be congruent to each other. This will help us later on in the chapter, like 5.3. All right, so we're going to look at our example. I'm going to tell you right now this example is easier if you take the triangles apart. So I'll highlight them, and then I'm going to redraw it. So this is the triangle I just highlighted. It's got A, C, D. I will say there's like 6 ways to solve this triangle. I'm going to try to teach you the least amount of work way, but it's up to you. You'll want to take any information at each angle. At angle A, there's an arc and there's a 45. So there's an arc and there's a 45. How you doing, Braden?
Doing amazing.
Wonderful news. Have you drawn this?
Yeah, I've already done
You already answered the question?
Yep.
Wonderful news. Angle C. So most people try to transfer these two arcs, but they're not at like the obtuse angle C. They're at BCD, not ACD. So there's no information here that we can copy over. But at angle D, we got two arcs and 30 degrees.
I've already done this.
You just haven't answered the final question.
Yeah, I know.
Okay. You're almost done, though. That's one way to do it. That's what I'm saying. There's a bunch of ways. All right, so that's our first triangle. Are y'all okay with it? Okay. The second triangle, if you can see it, is this one. And it is BDC. At angle B, you've got one arc. At angle D, like BDC, there's not any information about the whole angle. This 30 degrees and these arcs were for the other triangle. And then angle C has these two arcs. So we're trying to find BDC. What is the vertex of BDC? D, right? So BDC, we're trying to find this angle. Okay, in this triangle, we know angle B is how many degrees? 45. We know angle C is how many? 30. So then angle D, we're going to add them. What is 30 plus 45? 75. Subtract from 180. 105, which is correct. Measure of angle BDC. I just said at the beginning there's a bunch of ways to solve this. I will show you Braden's way.
Oh, wow.
That's great. Feel special. All right, here's the way Braden did it, and a way you can do it as well. You can fill in. These two are congruent, right? I just highlighted them. They're congruent. So this is 30 degrees, correct? Okay. This one has one arc, so it is 45 degrees. You can look at this and know it's a triangle, correct? How many degrees are in a triangle? 180. So we have 30 and 30, which is 60. So how much is left for this angle up here? 120, which means what is this angle going to be? 60. It's a linear pair with 120. Which means across from it would be 60. You got another triangle. You got 60 and 45, which means how many degrees is that? 105. Subtract that from 180, and that is 75. I'm getting there.
May I please get Devin Page to the front office?
Yes, ma'am.
Thank you.
I don't remember doing anything.
You still want BDC. So what is the last step you had to do, Braden, to find BDC? Yeah. You add 30 and 75, which still makes 105. So you can use whatever method you want, whatever works for you.